All right, so starting off with chapter 4, section 1, we're talking about inverse variations, okay? What do you think of when you hear the term inverse? Opposite, flipped, okay? What's the inverse of increasing? Decreasing, okay? What do you think of when you hear the term variation?
Like different stuff.
Many different things, okay? How they relate to each other. So like this is a variation of this, they relate to each other. Okay, so talking about inverse variations mostly today. So if I look at this table, this is not in your notes yet, okay, let's talk about inverse. What's happening to the x values?
Increasing.
The x values are increasing. What are happening to the y values? Decreasing. So do you agree x and y are inverses of each other?
Yes.
What else do you notice about that table? Okay. What else do you notice?
It increases weirdly.
What'd you say?
It like has a weird increase.
Right, once you get to here. What do you notice here? 1, 2, 3, 4, 6, 12. 1, 2, 3, 4, 6, 12. They are the same thing. It is not always going to happen like that, but that's something to notice here. Okay, x's is increasing, y's are decreasing. That's the inverse. Okay, variation is how they relate to each other. Okay. When we think of x and y, what do we think of? What do those represent? When we talk about x values and y values? Coordinates, right? We always think of these as x, comma, y. That's still exactly what they mean. They still mean x and y coordinates. Okay? When we talk about variation, it's how they relate to each other. We're going to call that k. Constant of variation. Yes, constant does not start with a k. Okay? But K stands for our constant of variation. How does y and x relate to each other if I'm just looking at 1 and 12? Or if I even look farther, 2 and 6. What are all of these going to relate to each other? They're all going to go into each other, but does that happen on 3 and 4? No. What happens if I multiply these together? 1 times 12. 12. What if I do the same thing here? Right, we talked about this last year with the variations. Are all of these, when we multiply these, going to equal 12?
Yeah.
Yes. That means that these are inverse relations of each other. Inverse variations of each other. Okay? So, if all the k values match, so all of these are 12, that means it's an inverse variation. Okay? We know it's an inverse because x's are increasing, y's are decreasing. They're the opposites of each other. Okay, the constants or the variation, they all have the same variation number or constant of variation. Okay, so yes, this is an inverse variation.
So it's inverse is when they all match, or when the outcome matches?
That's the variation part.
The variation matches?
Yes. Yep. Okay, so look at a similar one here. How can I determine if these are inverse variations? What do I need to figure out?
1 time.
I need to figure out. What'd you say?
If it's increasing on the top and decreasing on the bottom.
Oh, I like what you said there. It does not matter which one's which. It does not matter which one's which. But is one of them increasing, one of them decreasing? Yes. X's are increasing, Y's are decreasing. So we're good with inverse. How do I figure out if there are a variation of each other? Multiply what? Multiply the x times the y. So 1 times 20 is 20. 2 times 17?
34.
Do I need to keep going? Why not?
They don't equal each other.
Right. These already broke. These don't equal each other. So can this be a variation? No. So that cannot be an inverse variation. Okay? Yep. For these tables, yes. Okay? I want you to go ahead and try 1A and B. All right, so the directions say determine if each table of values represents an inverse variation. So, inverse, what does that mean?
Opposite.
Right, and one between x and y, what's happening? One is increasing, the other is decreasing. Yep. So, is that happening here? X is increasing, y is decreasing. In order to tell the variation, what do we need to find? We got to figure out what the constant of variation is, or that k. Okay, so multiply 1 times 25.5 is 25.5. 2 times 12.75. Can I just assume the rest of these?
Yeah, so how far should we actually go?
The whole way. Okay, you cannot assume once these first two match, I can't just say, oh, okay, this is a constant of variation, because this fifth one couldn't match. Okay, so what's 3 times 8.5? 5 times 5.10? 6 times 4.25? And 15 times 1.7. So is this a inverse variation? Yes. Okay, so you want to check all of them until you know for sure. Okay. On B, is it an inverse?
Yes.
Yep. X's are decreasing, Y's are increasing. How do we figure out the variation? Right, we got to figure out what that k value is. So I'm going to back up a little bit. On A, what was my k value? What's my constant of variation? 25.5. Yep, so if it ever asks you what your constant of variation is, it's that k value. Okay, now going back to B. What's 6.6 times 3? 19.8. So if this is if this is an inverse variation, what should the rest of these values be? Also 19.8. 5.5 times 5.
27.5.
What is it?
27.5.
Do we need to check the rest of these?
No.
Why not?
Because it's not.
It's already not one because these two don't match.
Oh, what are constant?
There is no constant variation. Yep, if it doesn't match, that means there's no constant of variation. No. Moving on to inverse variations and using them to find values. Okay, so the inverse variations, looking at this table, is this an inverse variation? Yes, why? K is the same and it's increase and decrease. Okay, what is my constant of variation? 24, because that's what we got every single time. So if I said, I'm going to use this one as an example, 4, 6, and 24. Write this formula down on the margins of example 2. Y equals K over X. This is going to be your inverse variation equation that you're going to use. Y equals K over X. Okay, so if I use this example right here, what is my Y value? Y value is 6 equals, what's K? 24. What's X? 4. What is really happening here? What operation's happening? Division. So does 6 equal 24 divided by 4? 24 divided by 4 is 6. So this is how we can use to find values that are down the road down here if we needed to. Okay, so keep this equation, circle it, box it, highlight it, something. That is the equation you're going to use. Okay? So look at an example here. If I told you that X is 10 and Y is 3, what else do I need to figure out in order to help me find other values? The K value, okay? What was that equation that I just told you? Y equals K over X. So plug in these two values to figure out what K is. So what I want to ask real quick, what do I mean by substitute or plug in?
Put it like X for X, Y for X.
Right. If X is 10, that means I'm taking 10 and I'm plugging it in for that X value. So is there going to be an X anymore? No. Okay, it turns into 10. So do I know what Y is?
3.
Y is 3. Do I know what K is? No. Do I know what X is? Yes. Raise your hand if you don't like fractions. Right. We always want to get rid of them when we can. How can I get rid of that fraction? I'm going to multiply by 10. What I do to one side, I have to do the other. So what's 3 times 10? 30. Remember over here, these 10s cancel out. So I have 30 equals k.
Do we have to do it that way?
The way you're thinking about it is the same way that I just did it.
Yeah, but like we don't have to put it.
No.
Cause I won't show my work for that.
Wait, what's
Nope.
the way you taught us before then? You said that.
So now if we wanted to find the y value for when x equals -6, now we have our important constant and variation to help us. Okay, so we're still going to use the same equation, y equals k over x. So this time, do I know what y is?
Yes.
I don't. That's what I'm looking for, right? I don't know what y is. Do I know what k is? Do I know what x is? Yes. So, again, what's happening here? Division. So y equals 30 divided by -6? -5. So our y value would be equal to -5. Okay. Let's look at that you have in your notes. Change that 1/2. Change that to a 2.
Are there going to be fractions?
On this example, yes, there will be, but on your homework assignment, I don't think there is.
That's probably.
Okay, not sure. So when we're trying to find an equation that represents the inverse variation, what is my equation that I'm going to use? Y equals k over x. So it wants us to write an equation that represents the inverse variation given our x equals 6 and our y equals 2. So all it wants us to do is just plug those values in. Yep, so y is 2. What is k? Don't know. What is x? 6.
That's it.
That's all it wants us to do for part A. Okay? For part B, it wants to know what is the value of y when x is 15. Can I figure that out right now? What do I need in order to help me figure that out? I need k, right? How do I solve what I have right here?
Times 6.
Multiply by 6 on both sides. 6 times 2? 12 equals k. So now we're going to use this same equation. Y equals k over x. Do I know what y is? I'm on part B.
Yes.
Do I know what y is? No. Remember, I'm looking for y.
Oh, we had it in the top.
Right, but now I'm on a different problem. I'm looking for y when x is 15. So what's k?
12.
12. What's x? 15. Okay, now, can I take 12 divided by 15? Not evenly. What do you get if you type that in your calculator? You get 0.8. Okay, let's practice. How can I write this as a reduced fraction? Right, we want to divide it by a number that goes into both, which would be 3. So what's 12 divided by 3?
4.
4. 15 divided by 3?
6. Okay.
Yep. So you get y equals 4/5 or y equals 0.8. So I want you to notice the whole time you are using this equation here. Okay?